Question 1. Does Rolle's theorem apply to the function f of x equals cosine x on the interval pi over 6 to 5 pi over 6? And then explain. Right? I'm going to write down the three conditions of Rolle's theorem. The first one would be that f of x is continuous. The second condition would be that f of x is differentiable. And then the third step is going to be that f of pi over 6 is equal to f of 5 pi over 6. All right, so first one, is f of x continuous? If I looked at the cosine graph simply just looks like this. This is definitely a continuous graph, so I can put a check on that. The next one would be, is f of x differentiable? Couple things that I could look for if I was looking at the graph is, are there any sharp turns there or not? But I'm going to actually take the derivative. If I take the derivative of cosine x, that's going to give me negative sine x. And then if I think of negative sine x, is there anything I can't plug in for x? And the answer is no, so it definitely is differentiable. Okay, and then the third thing, f of pi over 6 equaling f of 5 pi over 6. Pi over 6, if I plug pi over 6 into the original function, which is cosine, I'll get the square root of 3 over 2. And f of 5 pi over 6, the cosine of 5 pi over 6, just write that down, is going to equal negative square root of 3 over 2. So those two do not equal each other, so no, Rolle's theorem does not apply, and my reasoning could be, I'm just going to simply say, because f of pi over 6 does not equal f of 5 pi over 6. Okay, question 2. For the function f of x equals negative 1 over x, find the point or points guaranteed by the mean value theorem on the interval negative 3 to negative 1/2. Okay, mean value theorem. I know the essence of the mean value theorem is that at some point the derivative will equal the slope. So this is pretty much a three-step process. First of all, I'm going to find the derivative. And rewriting negative 1 over x would be negative 1 x to the negative 1. The derivative will be 1 x to the negative 2, or 1 over x squared. So done step 1. Step 2 is to find the slope. Well, I need 2 points to be able to find the slope. And you'll notice negative 3 and negative 1/2 are x values. To get the y values, we're going to go back into the original equation. And if I plug negative 3 into that original equation, I am going to get 1/3. And if I plug negative 1/2 into that original equation, I'm going to get 2. So if I find the slope, this is going to be 2 minus 1/3 over negative 1/2 minus negative 3. That will give me 2/3. All right, and then from here, my third step is just to take the derivative and set it equal to the slope. So I'll have 1 over x squared is equal to 2/3. I'm going to cross multiply. So I'll get 2x squared equals 3. Divide both sides by 2. I'll get x squared equals 3/2. And then to get rid of a square, we'll square root both sides. So I'll get x equals, don't forget I get plus or minus the square root of 3/2. And then from here, to see if I should use plus or minus or both, the interval just goes from negative 3 to negative 1/2, so the negative is the option I'm going to choose. So the point guaranteed by the mean value theorem would be happening at negative square root of 3 over 2. Okay, problem 3. The management of a large store wishes to add a fenced-in rectangular storage yard of 20,000 square feet, using the building as one side of the yard. Find the minimum amount of fencing that must be used to enclose the remaining 3 sides of the yard. Okay, the first thing that I'm going to do is draw a rectangular yard with the building as one side. So I will just need to cover x, y, and y. All right, the biggest thing on this one, I want the minimum. What do I want the minimum of? The amount of fencing. So I'm going to call that FF for fencing. This is the one I'm going to have to take the derivative of. So my amount of fencing, I'll need 1x and I'll need 2y's. So that's the one that I need to take the derivative of. So my side trip is going to be other information. They did tell me that I have 20,000 square feet, which would be an area. So I'm going to have 20,000 is going to equal the area of this rectangular storage yard, which would be x times y. And then I'm going to solve this for either x or y. I'm actually going to solve it for y. So I am going to, I labeled it wrong. I'm going to actually, I think I'll make it easier. I'll solve this for x. So I'll divide both sides by y. So I'll get x equals 20,000 over y. So now I'm going to have f equals 20,000 over y plus 2y. Right, once I have that formula, the next step would be to take the derivative. And I'm actually going to rewrite this one more time. This would be 20,000 y to the negative 1. So the derivative is going to be negative 20,000 y to the negative 2 plus 2. I'm going to rewrite that as negative 20,000 over y squared plus 2. And if I'm looking for a minimum or maximum, I'll find the critical number, so I'll set that equal to 0. I'm then going to subtract 2 from both sides, so I'll get negative 20,000 over y squared is equal to negative 2. And then I will cross multiply, so I'm going to get negative 20,000 equals negative 2y squared, which will give me negative 10, or actually just 10,000 equals y squared. If I square root both sides, I will get y equals 100. Then I'm going to go back up into my side trip. If I get x equals 20,000 over 100, that will give me 200. So it does not say to find the dimensions, it says to find the minimum amount of fencing. So my fencing is going to be x plus 2y, so it's going to be 200 plus 2 times y, which is 100. And if I figure that all out, that will be 400, and my units will be feet. So I will need 400 feet of fencing. Okay, problem 4. Find the absolute extrema of the function f of x equals 10 over x squared plus 1 on the interval negative 1 to 2. Okay, I know with absolute extrema, we need to find the critical number. So critical number. And then we're going to evaluate f at the critical number and endpoints. This one will not involve us drawing an f prime chart. Okay, so to find the critical number, I need to find the derivative first. So I notice on this one, actually, I'm going to rewrite this as 10 x squared plus 1 to the negative 1 because there's a constant up top. I don't have to apply the quotient rule. And so from here, I'm going to do a u substitution. So this will be 2u to the negative 1. And then du is going to be 2x. Alrighty, so f prime will end up being negative 10 u to the negative 2 times the derivative of the u, which will be 2x. So if I rewrite this, I will get negative 20x over u squared, so x squared plus 1 squared. Okay, now I need to find critical numbers. Critical numbers occur where the derivative either equals 0 or where it's undefined. So the derivative will equal 0 when x equals 0. And looking at the denominator actually will never equal 0 because of this plus 1. So 0 is my only critical number. So once I do that, I'm going to evaluate f at 0, and then I'm also going to evaluate it at the endpoints. Okay, when we evaluate f, we are plugging it into the original equation, just saying. So if you plug 0 into the original equation, you will get 10. If you plug negative 1 into the original equation, you're going to get 5. And if you plug 2 into the original equation, you're going to get 10, right? And this says to actually find the absolute extrema. So the absolute max, it didn't say where it is, it says what is the absolute max. The highest y value that I ever reach is 10. And then my absolute min will be the lowest y value that I ever reach, which is 2. Okay, problem 5. Use a of t is equal to negative 32 feet per second squared as the acceleration due to gravity. A ball is thrown vertically upward from the ground with an initial velocity of 50 feet per second. For how many seconds will the ball be going upward? All right, so we're talking something about velocity, and I want to know how many seconds the ball will be going upward. So I'm going to go ahead and get velocity. If I started acceleration being negative 32, to get velocity, it's going to be the integral of the acceleration. And so the velocity is going to equal negative 32t, and then don't forget your plus c. It does tell me that I have an initial velocity of 50, which means the velocity is 50 when the time is equal to 0. And that's going to be my c is equal to 50. So now I have velocity is equal to negative 32t plus 50. Right? So I've got a velocity formula. It says for how many seconds will the ball be going upward? Well, I know the ball will be going upward until the velocity changes sign. So I would like to figure out where would the velocity change sign, and I'll do that by setting the velocity equal to 0. And if I do that, I'll get 32t is equal to 50. And 32t, excuse me, if I divide both sides by 32, I will get t equals 1.5625. Okay, one thing that I do need to make sure is that the ball is actually going to go up and then it's going to go back down. So I am going to do a velocity chart. And when I plug let's say 0 into the velocity formula, I'll get a positive answer. And then if I plug 2 into the velocity formula, I'm going to get a negative answer. So indeed, the ball is going up for 1.5625 seconds.